All right, boys and girls, we're starting today section 5.1, which is using fundamental identities. And so in this chapter, you're going to evaluate, simplify, you're going to learn some new additional trig identities, and you're going to be solving trig equations, okay? We're going to start with example 1 and page 351. This example is not in the book. But basically what you're going to need is you're going to need the trig identities on the previous page, page 350. Some of those you might already have in a flashcard, okay? So I would just add the ones that you don't have in a flashcard, or you can just utilize page 350, okay? All right, so pretty much this, let me read you the directions. They want you to use the values of sine of x equals 1/2 and cosine of x that's greater than 0 to find the values of all 6 trigonometric functions, okay? So just before we get started, I'm just going to show you how I'm going to use my unit circle, okay? If sine of x is greater than 0, then we know that if sine of x equals 1/2, we know that sine of x is greater than 0. And then we were told that cosine of x is greater than 0. So at which quadrant does this happen? And out of all quadrants, we know that sine of x is the y value and cosine of x is the x value. So if it's greater than 0, we're looking at values that are positive. And so that happens at quadrant 1. That means whatever values we end up with, they'll all be positive, okay? All right, let's get started with the first one. So the only value that I'm given is sine of x, and we know that sine of x is also the reciprocal of cosecant. So technically, I can find the value of cosecant, because cosecant of x is the same as 1 over sine of x, okay? So it's the reciprocal. So if you do the reciprocal of sine of x, it's like doing 1 over 1/2. And you guys, this will just simplify to 2, okay? So we found our first value. So cosecant of x equals 2, okay? So they want us to find all 6 trig functions. So I just found my second one. I was given my first one, but I found my second one, okay? And this is just a trig identity. Okay, so we know sine, we know cosecant. Now, if you look at your trig identities, what other thing can you find? Well, none of the reciprocal identities will work for this one, but you could probably use one of the Pythagorean identities. And since we have sine and cosecant, I could probably use, and I'm going to use a different marker for this so they could stand out. Okay. I would probably use, well, there's a couple I can use. I'm going to go with sine of squared, I'm going to go with sine squared of x plus cosine squared of x equals 1. So this is one of the Pythagorean identities, okay? So the reason why I chose this one is since I know what sine is, I could probably find cosine. So now I'm just going to substitute my values, okay? Or actually, let's isolate cosine, okay? So to isolate cosine squared x, I would subtract sine squared x to both sides. So I would get 1 minus sine squared of x. And then to get the cosine, I would take the square root, okay? So I actually like doing this first because then I already have it by itself. So then I could just plug in what I know. So the square root of 1 minus sine squared x, which is just 1/2. Okay. So 1 minus 1/2 squared. Okay, and then you just do some simple algebra. Whenever you square a fraction, it's the same as squaring the numerator and the denominator. So this is the same as 1/4. So this is 1. I could just rewrite it as 4/4, okay? And 4 minus 1 is the same as 3/4, or the square root of 3/4, okay? And I ran out of room there, so I'm just going to bring it over here, guys. So cosine of x is the same as square root of 3/4. And notice 3/4 is all under the radical. So when I square square root a fraction is the same as breaking it apart. So square root of 3 over square root of 4. So this is just algebra, okay? And the square root of 4 is 2. So I just found another one, okay? So cosine of x is the same as square root of 3/2, okay? And so there's that, okay? So again, I'm using a property that I already know. And so since I have cosine, I have cosecant, I have sine. Again, I want to work with what I have. I know that I could technically find tangent and even cotangent, because tangent is sine over cosine. So I can work with those two, okay? I'm running out of room here, so let me pull another whiteboard. Okay, actually, I think I could squeeze it in here. I just adjusted my camera. So I'm going to work with tangent of x, okay? So tangent of x we know is sine of x over cosine of x, okay? So sine of x is 1/2, and cosine of x is square root over 2. And we've talked about this before. Dividing a fraction by a fraction is the same as multiplying by the reciprocal. So 2 times radical 3, okay? And then if the 2's will cancel out, so you just have 1 over radical 3. And then don't forget, you're not allowed to have radicals in the bottom. So I'm going to multiply by radical 3 to the top and the bottom, numerator and denominator. And the 3's and square root of 3 times square root of 3 should just give you 3. So my final answer should be tangent of x equals radical 3/3. Okay? Sorry, my markers are getting a little bit big at the end. So I just solved for another one. Okay? Again, it's mostly algebra, but using your trig identities. So they want us to find 6 of them. We just found sine, cosecant, cosine, and tangent. So we found 4. Again, technically now, since I know tangent, I can find cotangent. Okay? I'm trying to keep it all in the same whiteboard, so I think I can do it here, okay? So let me grab a different marker. So we know that cotangent of x, it's just the reciprocal of tangent of x. So 1 over tangent of x. So technically all I have to do is just flip what I already have. So this would be 3 over radical 3, okay? But the same thing's going to happen. You're not allowed to have radicals, so I'm going to multiply by radical 3 top and bottom. And then what we're going to end up with is, I don't think I'm going to have room, but I'm going to try to squeeze it in. 3 radical 3 over 3, okay? And then there's a 3 as a coefficient and there's a 3 as a denominator, so those 3 will cancel out. So then cotangent of x should just be radical 3, okay? Awesome, you guys. We just found 5 of them, okay? And if you recall, we were only given one at the beginning, sine of x, okay? And now we found mostly all of them. So which one are we missing? We have sine of x, cosecant, tangent, cosine, and cotangent. Okay, so we're missing secant. And secant is just the reciprocal of cosine. So here we go. I think I'm going to squeeze it in here. Okay, so let me just grab a different marker. So secant, trying to make sure I'm not in the frame. So secant is the reciprocal of cosecant, so 1 over cosine of x. And if you recall, cosine of x is square root of 3 over 2, so I just have to do the reciprocal. So this would be 2 over radical 3. But there's a radical in my denominator, so multiply by radical 3 to the top and the bottom. And so now I end up with secant of x equals 2 radical 3 over 3. And there's nothing I can simplify there. Okay? So this would be my secant. So notice you used all sorts of trig identities to solve. Okay? And so now you found all 6. And you guys, I apologize. Hopefully it's not messy. Let me see if I can zoom out. Okay, well, this is the best that I can do. Okay? So you can always pause it. Okay. All right, awesome. I actually don't feel like I need to do another one. So now I'm going to have you guys try one. And then I'm going to have you guys try one on your own, okay? And then if you guys need help, just jump in and I'll help you.